Welcome to the Deep Dive, your shortcut to becoming well-informed. We sift through the sources so you don't have to.
We do the reading, you get the knowledge.
Today, we're diving into the fundamentals of programming with Python. It's a really popular language, great for beginners.
Absolutely. And our source today is a pretty comprehensive video tutorial from YouTube by CodeAvecJonathan. It's called Apprendre, Python, Tuto, Programmation, Complete, Débutant. It's in French, but the concepts are universal.
Right. And your mission, should you choose to accept it, is basically to get a solid handle on the core Python ideas, and importantly, know exactly how to get started writing your own code without feeling totally overwhelmed.
Yeah, that initial hump can be tricky.
Yeah.
Okay, so where does the tutorial kick things off?
Well, logically, it starts with actually getting Python onto your computer, the setup.
Makes sense. You can't cook without ingredients, right?
Exactly. First things first, installing Python itself. The video points you to python.org. Pretty straightforward.
It stresses grabbing a Python 3 version. There's this older version, Python 2.7.
Yeah, the video mentions it's kind of legacy software now. As a beginner, you definitely want Python 3.
Right. And don't get too hung up on the specific numbers, like is it 3.8 or 3.9 or 3.0?
Good point. The tutorial suggests the core learning is the same. Just get the latest stable Python 3.
Okay, so download from python.org. What about actually installing it?
The tutorial covers Windows and Mac OS. For Windows, there's one really crucial step during the install.
Let me guess. The path variable.
You got it. There's a checkbox that says something like add Python to path. You really, really want to check that box.
Yeah, it saves a lot of headaches later. It basically tells Windows where to find Python when you want to run something.
Exactly. And the video shows how to double check it worked using the command prompt cmd and typing Python version.
And for Mac users, is it similar?
A bit different. On macOS, you download a PKG file like a standard Mac installer. You run that.
Okay.
And then you verify it using the terminal app, not the command prompt. The command is slightly different too. Python 3 version, note the 3.
Got it. So Windows uses Python, Mac uses Python 3 in the terminal, usually. Good distinction. The source didn't cover Linux, though.
No, it focused on Windows and Mac. But the Python code itself, the concepts we're talking about, they'll work the same regardless of your operating system.
Right. The fundamentals are the same everywhere. Okay, Python installed. What's next? You need someone to actually write the code, right?
Precisely. The development environment, or IDE, think of it as your coding workbench or text editor supercharged for code.
And the tutorial recommends a couple.
Yeah, two main ones. First up is PyCharm. The video calls it the reference IDE for Python.
JetBrains. Yeah, PyCharm's very popular, very powerful.
And there's a free version, the Community Edition, which is great for beginners. Available for Mac OS and 64-bit Windows. Grab it from the JetBrains website.
Installation, pretty standard.
Seems like it. For Windows, the video shows just accepting the defaults mostly. There's an option to associate .py files, which can be handy.
Yeah, on Mac. Probably the usual drag and drop.
Exactly. Drag the PyCharm icon to your applications folder. The tutorial does mention you might get a security warning the first time you open it on a Mac.
Oh yeah, gatekeeper.
Right. But it says just click open, it's fine.
Okay, and then you're in.
Yep. Then you create your first project, and inside that, your first Python file, often called main.py by convention.
And the tutorial shows the classic first step.
It does. Writing print, bonjour Toto, remember the source is French, and then hitting the run button right there in PyCharm.
And you see bonjour Toto appear. That's the magic moment. Your code did something.
It really is. But what if PyCharm feels a bit heavy, or you're on an older machine, maybe 32-bit Windows?
Good question. Does the tutorial offer an alternative?
It does. Visual Studio Code or VS Code.
VS Code. Also hugely popular. Lighter weight than PyCharm, maybe.
Generally considered so, yeah. You download it from the Microsoft website, code.visualstudio.com.
Installation. Similar checks.
For Windows, again, mostly defaults. But just like with Python, make sure the Add to Path option is checked during installation. Super important.
Okay, crucial check again. Mac install.
Even simpler, unzip the download, drag the VS Code app to Applications, done.
But wait, VS Code isn't Python specific like PyCharm, is it?
Correct. So there's one extra step with VS Code. You need to install the official Python extension. You do that from within VS Code itself in the extensions marketplace.
Right, that tells VS Code how to understand and run Python code. Makes sense.
After that, it's a similar workflow. Create a new file, maybe call it test.py. The key is that .py ending.
The file extension, yeah. Tells the system it's a Python file.
Save it, type your print, bonjour Toto, and run it. VS Code has a run button, too, once the extension is installed.
Okay, so now we have Python installed, and we have our coding environment, PyCharm or VS Code, set up, ready to actually understand programming.
This is where the tutorial uses a really neat analogy. It compares programming concepts to a cooking recipe.
Ooh, I like that. Makes it much less abstract. So how does that break down?
Well, variables are presented as your ingredients, the data you work with.
Okay.
Like number of figs equals 4, or maybe ingredient cheese. You're giving a name to a piece of information.
Got it. So number of eggs is the variable name, and 4 is the value it holds.
Precisely. And the tutorial makes a point about the difference between for assigning a value and which you'd use later to check if two things are equal, a common beginner confusion.
Ah, good point. Assignment versus comparison.
It also shows how variables can adapt. Like you could ask the user how many people are eating and then calculate the number of eggs needed based on that input. The variable holds the result.
So variables are like named storage boxes for information. What about the actions in the recipe?
Those are functions, things like crack eggs or mix ingredients.
Okay, so casser des souffles or mélange in the French examples.
Exactly. Functions let you group related lines of code together under one name. This makes your code organized, easier to read, and reusable.
Reusable how?
Well, instead of writing the steps to crack an egg multiple times, you just define the crack egg function once, and then you can just call crack egg whenever you need it.
Ah, I see. And functions can take instructions.
Yes, those are called parameters. Like crack eggs tells the function how many eggs to crack. And functions can also give you back a result, like maybe a function mix ingredients could return the finished batter.
Okay, variables are ingredients, functions are actions. What else is in a recipe? Decisions.
Yep. Conditions. The tutorial frames it as, if I have cheese, then I add cheese.
So if statements.
Right. Using the keywords if and else. Your program can check if something is true and do one thing if it is, and optionally something else if it's false. It's how programs make decisions.
Makes sense. And recipes often have repetitive steps, too.
They do. And that's where loops come in. Like for each person eating, crack one egg.
So instead of writing crack 4 times, you loop it.
Exactly. The video briefly mentions the two main types. For loops, often used when you know how many times you want to repeat, and while loops, which keep repeating as long as a certain condition is true.
Got it. Variables, functions, conditions, loops. That covers a lot. What about the recipe itself? The whole plan?
That's the algorithm. The tutorial describes it as the overall recipe or the specific way of doing things.
So the step-by-step instructions to achieve a goal.
Precisely. And it makes the point that there can be different algorithms for the same goal. You could have a basic omelet recipe, a super fast one, or an ultra gourmet one. Different steps, different outcomes, maybe different efficiencies.
Like different ways to sort a list of names or find the best route on a map.
Exactly. The tutorial mentions GPS and Amazon recommendations as real-world algorithms. It also gives a little nod to objects and object-oriented programming as a more advanced topic for later.
Right. Keep it focused on the fundamentals first. That cooking analogy seems really helpful.
I thought so too. So armed with those concepts, the tutorial then gets you to actually write that first proper program.
Okay. Back in PyCharm or VS Code, what does that look like?
You'd create a new project, maybe a folder called First Program, and inside it, that main.py file.
Right.
And the core thing introduced here is the print function. We saw it with Bonjour Toto, but this is where you learn it's your main tool for getting output, for seeing results on the screen.
The way you make the computer talk back to you.
Exactly. If you write multiple print statements, like print line 1, then print line 2, they appear on separate lines in the output.
Which demonstrates sequential execution, right?
Yeah.
Python just runs your code top to bottom, one line after another.
Precisely. Print is fundamental for seeing what's happening.
Okay, so we can display things. What about using those variables we talked about?
Good segue. The next step in the tutorial is storing and reusing data with variables. It shows how to declare one, like person name Alice.
Using the equal sign for assignment again.
Yep. And it covers the naming rules. Generally lowercase, use underscores instead of spaces, no weird characters or accents. And remember, names are case sensitive. Person name is different from person name.
Standard conventions. Makes code easier for others and yourself to read.
Then it shows how to stick strings together, which is called concatenation, using the plus sign, like print, hello plus person name.
Ah, but you need to be careful with spaces there, right?
Good point. Yes, person name holds Alice. If you just do hello plus person name, you get hello Alice. You need hello plus person name to get the space.
Little details matter.
It also clarifies the difference between using the variable name person name, which gives you its value Alice, and using the literal string person name, which just gives you that exact text.
Quotes make a text, no quotes make the variable's content. Got it.
Oh, and a neat little trick. If you just call print with nothing inside the parentheses, it prints a blank line. Useful for spacing out your output.
Handy. Okay, so we can store data and print things. How do we make it interactive? Get input from the user.
That's the input function. The tutorial introduces it as the way to pause the program and wait for the user to type something in.
How does that work?
You usually give it a prompt message inside the parentheses, like input, what is your name? That message gets displayed to the user.
Okay, it asks the question.
Then the user types their answer and hits enter. Whatever they type is given back by the input function, and you typically store it straight into a variable, like username, input, what is your name?
So the user's response gets stored in username.
Exactly. And a key programming rule is highlighted here. You have to define or assign a variable before you try to use its value. Can't print username if you haven't asked for it yet.
Makes sense. You need the box before you can look inside it.
The video shows a simple example. Ask for the name, store it, then print a personalized greeting like, hello, username.
Nice. Practical.
And then it gives you, the listener, a little exercise. Ask the user for their name and their age, then display a combined message like, you are called name, you are age, years old, adapting the French phrasing slightly.
Good little challenge. Does it show the solution?
It does. It shows storing the name, storing the age, and then using string concatenation again. Print. You are called A plus name plus age, you are clam plus age plus years old.
Ah. But there's a catch there, isn't there, with the age?
A very important one the tutorial points out. Input always gives you back a string. Always text.
Even if the user types in 30. Python sees it as the characters 3 and 0, not the number 30.
Exactly. So that concatenation works fine because you're just joining strings together, but you can't do math with that age string yet. We'll get to that.
Okay, good point to flag early. What about making code understandable? Notes for yourself or others?
Comments. The tutorial covers them well. Single-line comments start with a hash symbol, hashtag. Everything after the hashtag on that line is ignored by Python.
Useful for quick notes.
And for longer explanations or maybe temporarily disabling a whole block of code, you can use multi-line comments. These are enclosed in triple quotes, either double die or single there.
Right, so comments are purely for humans. Python skips right over them.
Correct. Good for documentation, explaining why you did something, or just turning off some code while you test something else. The video even shows the keyboard shortcuts for commenting lines quickly in PyCharm and VS Code.
Very handy time savers. Okay, so we mentioned that input gives back strings. What if we want to treat that age as a number?
Now we get into data types. The tutorial highlights the difference between the string 30 text and the integer 30, a whole number. No quotes means it's a number.
And Python treats them very differently.
It introduces the type function, which is super useful. You can do print type age, and it might tell you class str if age is still a string, or class int if it's an integer.
A good way to check what kind of data you're actually working with.
Then it demonstrates the problem. If you try to do print, next year you will be, plus age plus 1, where age is still the string 30, Python throws a type error.
Right, you can't add a number 1 directly to a string. 30 does make sense mathematically.
So how do you fix it? If you want to display it, you need to convert the number part to a string first. You use the string function, like string number.
So if you calculated next age equal 31, you'd need print next year plus string.
Exactly. But what if you want to do the calculation in the first place? You need the age as a number before you add 1.
So we need to convert the string from input into an integer.
Precisely. And for that, you use the int function. If age string holds 30, then age number into age string will put the actual number 30 into age number.
Okay, string converts to string, converts to integer.
What happens if the user doesn't type a number when you ask for their age? What if they type 30 or just mash the keyboard?
Then int 30 is going to fail, isn't it?
Big time. It raises a value error. Your program crashes. Not very user-friendly.
So we need a way to handle that possibility. Error handling.
Exactly. The tutorial introduces the try.except block. It's like saying, okay, try doing this potentially risky thing.
Like age number into age string.
And if a specific error happens, like a value error, then do this instead.
Like print an error message. Please enter a valid number.
Precisely. You put the risky code under try, And the fallback code under except value error. It stops the program from crashing and lets you handle the error gracefully. It's like a safety net.
That's a really important concept. Building robust programs means anticipating errors.
The tutorial also points out you need to think about what happens after the try except. If the int failed, maybe your age number variable never got a value, so you need to handle that later in your code.
Right. Maybe you loop back and ask again, or use a default value. It also mentions an else block.
Yeah, briefly. Code under else after the except. Only runs if the try block completed without any errors. Useful sometimes.
Okay, so handling input, converting types, handling errors. What about doing things repeatedly? You mentioned loops earlier.
Right. The tutorial dives into the while loop first. This loop keeps executing a block of code as long as a certain condition remains true.
So while something's just true, do stuff.
Exactly. The crucial thing is that something inside the loop needs to eventually make that condition false. Otherwise, you get an infinite loop. The program gets stuck repeating forever. You usually have to force quit it.
Been there, done that. So you need an exit strategy for your while loop.
Always. The tutorial gives an example. Asking for a password repeatedly. While correct password, ask again. Once the user enters the correct password, the condition becomes false, and the loop stops.
Makes sense. Can we combine this with the age input?
Perfect application. The tutorial shows exactly that. You use a while loop to keep asking for the age until the user enters something valid.
So you'd have the input and the try, except for int, inside the while loop.
Precisely. Maybe you have a variable age valid. Qui is false. The loop runs while not age valid. Inside, you try to get the input and convert it to int. If it works, you set age valid, true. So the loop stops next time and maybe print the age. If you get a value error in the except block, you print an error message. But age valid stays false. So the loop runs again, asking for input again.
That's a really common and useful pattern, looping until you get valid input.
Definitely. Okay, so your code is getting more complex now. What happens when it doesn't work as expected? It runs, but does the wrong thing, or you're not sure why a value is what it is.
Debugging time. Does the tutorial cover that?
It does. It introduces the concept of breakpoints and using the debugger built into the IDEs.
Lifesavers. Explain breakpoints.
They're like stop signs for your code. In PyCharm or VS Code, you click in the margin next to a line number, and it usually puts a red dot there. And that's a breakpoint.
Okay, so you mark a line. Then what?
Then you don't just run the program normally, you run it in debug mode. Both IDEs have a special button for this. Often looks like a little bug or insect.
Aptly named.
When your program reaches a line with a breakpoint, it pauses execution right there.
And then you can inspect things.
Exactly. The debugger interface pops up. It shows you the values of all your variables at that exact moment. You can see what username holds, what age number is, etc.
Super useful for figuring out why something has the wrong value.
Totally. And then you can step through the code. There's usually a step over button. Clicking it executes the current line and pauses on the very next line.
So you can watch your program run line by line, seeing how the variables change.
Precisely. It's invaluable for understanding the flow of your program and pinpointing exactly where things go wrong. Much better than just adding loads of print statements everywhere.
Agreed. Using the debugger is a key skill.
The tutorial then suggests more practice with conditions, if, elif, else. It gives an exercise. Modify the name input part. Check if the name entered is empty, just spaces maybe. If it is, use a while loop to keep asking until the user actually types a proper name.
Combining loops and conditions again for input validation, a good practice.
Yeah, the solution shows how you might check if name equal or if not name inside a loop.
Okay, so programs are getting longer. How do we keep them organized? You mentioned functions earlier.
Right. The tutorial comes back to functions, introducing the def keyword properly. Def is how you define a function.
So def ask forage, followed by indented code.
Exactly. All the code indented underneath that def line belongs to the function askForage. That code doesn't run when you define the function, though.
Right. Defining is like writing down the recipe. It doesn't cook anything yet.
Perfect analogy. To actually run the code inside the function, you have to call it. You do that just by using its name followed by parentheses, askForage.
So def creates it, calling it, runs it.
Yep. And the tutorial touches on local variables. Variables created inside a function only exist inside that function. They're separate from variables outside or in other functions, even if they have the same name.
Encapsulation keeps things tidy, and functions can give back results.
Yes, using the return keyword. If your askForage function successfully gets a valid age number, it can finish with return age number.
And then when you call it,
When you call it, the function call itself sort of becomes that returned value. So you'd write userage, ask forage. The number returned by the function gets stored in userage.
Powerful stuff. Makes code modular. Does it give another exercise?
It does. Create a function ask for name that handles getting the name, including that loop to make sure it's not empty, and then return the valid name.
Good. Reinforces the concept. What about sharing information between functions? Or using variables defined outside?
This leads to a discussion about global variables versus function parameters. The tutorial briefly shows the global keyword,
Which lets a function modify a variable defined outside of it.
right, but it quickly adds that using global is generally discouraged. It can make it really hard to track where a variable is being changed, pass parameters into the function. We saw this briefly with crack eggs. The for was a parameter.
So you give the function the data it needs to work with when you call it.
Exactly. This makes functions much more self-contained and reusable. The tutorial gives an example. Modify the ask forage function so you can pass the person's name into it. Def ask forage.
So inside the function, you could use person name to make the prompt more personal, like input. Okay, person name, what is your age?
Precisely. You pass the information in as a parameter, rather than having the function rely on some global name variable existing somewhere else. Much cleaner.
Definitely the preferred way. More practice with this.
Yep. Another exercise. Create a function display person info name age that takes two parameters, the name and the age.
And inside it just does the printing.
Right. It would contain the two print statements, you are called name and you are age years old. Then in your main code, after you've gotten the name and age, maybe from your ask for name and ask for age functions, you'd call display person info, username, userage, passing in the values.
Nice. Separating the task of getting input from the task of displaying output. Good structure.
Okay, let's revisit conditions. What if you have more than just two possibilities?
Ifels. That's where elif comes in, right? Short for else if.
Exactly. The tutorial uses age categorization as an example. If age 18, print minor, elif age equals 18. Print just became adult, elif age 60. Print senior, elif, print adult.
So you can chain checks. Is the order important?
Very important. Python checks them in order. As soon as it finds a condition that's true, if or elif, it runs that block of code and then skips the rest of the elifs and the else for that chain.
Okay. So if you checked if age 10 before checking if age 60, someone who is 70 would match the age 10 first, and it would never check if they're a senior.
Exactly. You often need to think about the most specific cases first or structure it logically.
Makes sense. More conditions?
Yep, more exercises. Add conditions for almost adult, age 17, senior age 60, child age 10, reinforces elif.
Good. What about combining conditions, like checking for an age range?
Right. The tutorial covers and/or. To check if someone is an adolescent, say 12 to 17, you could do if age of 12 and age 18. Both parts must be true.
Okay. And/or.
For or, only one part needs to be true. Example. Checking if someone is a baby, age 1 or 2, if age 1 or age equals 2.
Got it. Does Python have shortcuts for ranges?
It does. The tutorial shows the more Pythonic way to check that adolescent range, if 12 equals age 18. Much cleaner. Reads like math notation.
Oh, that's neat. 12, age 18. Very readable.
Okay, shifting gears back to loops. We did while. What about the other one?
The for loop.
Yeah.
Usually for iterating a known number of times or over a sequence.
Right. The tutorial introduces the basic syntax using range, like for I in range 5.
What does that do?
It runs the indented code block 5 times. The variable I, you can call it anything, takes on the values 0, then 1, then 2, then 3, then 4, 1 for each loop iteration.
So range 5 gives you numbers from 0 up to, but not including 5?
Correct. Range 0, 5 does the same. The tutorial shows using this to get information for, say, 3 people. You'd loop for I in range 3, and inside the loop, you'd ask for name and age, maybe using I to personalize the prompt, like enter details for person I plus 1.
Using I plus 1, because I starts at 0, right? So you get person 1, person 2, person 3.
Exactly. It also introduces the idea of using a constant, usually a variable name written in all uppercase, like nm people equal 3, to control the loop. For mine in range, and on m people, makes it easy to change how many people you process later.
Good practice. Use named constants instead of magic numbers, like 3 scattered in your code.
Okay, quick detour into number types. We've mostly talked about integers, whole numbers. What about decimals?
Floating point numbers or floats.
Right, like height equals 1.75. The tutorial shows adding a height parameter to that displayPersonInfo function.
So now it's displayPersonInfo, name, age, height. Well, but what if you call it with only name and age?
Error. You'll get a type error about missing arguments.
So how do you make a parameter optional?
You give it a default value in the function definition, like def display person info, name, age, height, 0.
So if the caller doesn't provide a height, it automatically uses 0.
Exactly. And then inside the function, you might add an if check. If height 0, print f height, height. So it only prints the height if a real value, not the default 0, was provided.
Clever. Default arguments for flexibility.
Now, we've been using plus to build strings. Are there better ways?
Oh, yeah. String formatting. The tutorial covers a couple.
2 main ones besides plus day. First, F strings. These are really popular now. You put an F right before the opening quote of your string.
Like F hello name.
Exactly. Inside the string, you can put variable names or even expressions directly inside curly braces, and Python automatically inserts their values. F your name. You are 8 years old.
Much cleaner than lots of plus signs and strings.
F strings are great. Readability plus Derek. What was the other method?
The older percent formatting style. You put placeholders like percent for string or percent for integer in the string, and then follow the string with a percent and the variables to insert.
Like hello percent name?
Yep. Or for multiple values, name, percent, age, percent, name, age. You put the variables in a tuple, parentheses, after the percent.
F strings feel more modern and often easier to read, but good to know about percent formatting too. You might see it in older code.
Definitely. Finally, the tutorial circles back to the print function itself, showing a couple more tricks. What else can it do?
You can print multi-line strings easily by enclosing the text in triple quotes right inside the print. This is line 1, this is line 2, or just literally putting line breaks inside the triple quotes.
Handy for blocks of text.
Also, instead of concatenating everything into one big string with plus bay, you can just pass multiple items to print, separated by commas. Like print name, age.
And print handles the spacing.
It does. It automatically puts a space between each item. And a bonus. You often don't need to manually convert numbers to strings with strings when you do this. Print age works even if age is an integer.
Oh, that's convenient. Print is smarter than it looks.
So to pull it all together, the tutorial provides a summary, probably referring to that PDF mentioned in the source description. It recaps the key things.
Let's quickly list them. Variables and their types. String, int, float, boolean, naming rules.
Output, input for input.
Working with strings.concatenation, formatting with F strings or percent.
Converting types, pretty oversee, int uppe.
Comments, hashtag and.
Loops, while for condition-based repetition, with range, for counted repetition.
Functions, def to define, parameters for input, return for output, organizing code.
Conditions, if else, comparison operators, and or range checking.
And crucial error handling with try and except.
That's a really solid set of fundamentals covered there.
Absolutely. That gives you the essential toolkit to start building simple programs.
For sure. So you, our listener, should now have that foundational understanding of Python programming. But the key now is practice.
Definitely. Reading about it or listening to us is one thing. Actually doing it is another. Try stuff out.
Yeah, try building that little quiz we mentioned earlier. Use print to ask questions, input to get answers, to check if they're right, keep score with a variable.
It doesn't have to be complex. Just make the computer do something based on your instructions. That's where the learning really sticks.
Remember, this tutorial focused on the absolute basics. There's so much more out there. Object-oriented programming, working with files, using external libraries, building websites, games, doing data science.
The possibilities are huge.
Yeah.
But they all build on these core concepts. Variables, loops, conditions, functions.
So maybe the final thought for you is, what small, annoying task could you potentially automate? Or what simple idea could you bring to life using just these fundamental tools? Even simple code can be surprisingly powerful.
We'd be curious to hear what kind of projects you might imagine tackling, even as a beginner. What sparks your interest?
Let us know. And that wraps up this deep dive into learning Python fundamentals. Thanks for joining us.
See you next time on the Deep Dive.